Let's start out with our demotivational poster. Pessimism. Every dark cloud has a silver lining, but lightning kills hundreds of people each year who are trying to find it. Sort of matches our topic for today, which is electric motors. There's many different types of electric motors. There's DC, or direct current motors. There's AC, alternating current. And you're probably familiar with the single-phase variety, but most industrial motors are three-phase. So they've got three hot legs going into them, or three legs of power going in. In order to specify a motor, though, you have to select which type you want to use, and there's reasons for using various types in various applications, situations. Primarily being what type of power is available. So AC three-phase are by far the most common in industry as far as electric motors go. You have to choose what power and speed they're to operate at, the voltage, frequency, what kind of enclosure frame size. There's a lot of different things to select here. Let's talk about some of them as we go. Let's start off with the current type. Are we talking about the band, AC/DC? No, that's not what we're talking about. We're talking about alternating current and direct current, and I have a slide in just a minute that will help you understand a little bit more about electricity, at least in a way that helped me when I finally realized it. And of course, there's single-phase and three-phase in AC, and of course in direct current there's all kinds of different voltage levels and techniques for controlling speed in DC motors and different types. But what is AC current? What is this stuff? How does it work? Well, outside your home or business or apartment, wherever you've been, you've probably noticed a spike driven into the ground and a wire going to it. And then, of course, you've also plugged things into your outlet in your home or residence, wherever you are. And you probably wondered how these things related to each other. Well, it's actually pretty simple. That plug that you see, it looks kind of like a face with a surprised mouth open, right? That's what it looks like. But the mouth part is the ground, and that has a wire that literally is connected from that point to that rod that's driven into the ground. It's called ground because it's ground potential. It's the electric potential of the earth and the surrounding area. Now, what do I mean by electric potential? Well, gravitational potential is probably something you're familiar with. So you raise an object in the gravity field, you know that it has the potential to fall, right? I don't know why it's called potential. I think that's why. It has the potential to do work, maybe. But it's going to fall if you let it go. Well, electric potential is similar. Basically, electric potential is taking charges up to a higher potential level where they can fall. Where do they fall to? Well, to whatever reference that's at a different height. I mean, if I pick up an object and I say, how far will this fall? You will look and see how far away the floor is, right? But what if I take it and I hold it over a table? Well, that's a different reference. That's a different ground. That's a different potential, right? It won't fall all the way to the floor. It just falls all the way to the table, which may be less. What if I dug a hole in the ground that went down, 100 feet in the ground? How far can it fall then? A heck of a lot farther. That's a different potential. You see how the ground potential can move around. In the same way, electric potential can move around. We have to select a reference. Just like if I ask you how tall is the Empire State Building, your reference will probably be the street outside. Another way to select a reference is to say how far is the top of the Empire State Building above sea level. That's a different question, you see, because the potential or the ground potential is different. So electrically, there are different levels of potential, and ground in my house or in my office or in whatever building you happen to be in is defined or basically literally driven into the ground right outside the building typically. So that's the ground potential. Now, one thing you've probably studied are voltage dividers, where you have two separate resistors. And maybe this will make a little more sense now. You probably used Ohm's law and had to calculate current through the resistors and the output voltage and all these things, and you wondered what use it was, to anything. Well, there's a lot of uses for a voltage divider circuit, but in our context, I want to use it to help you understand electric potentials. So you see 0 volts down at the bottom. That would be our reference. That's where we've defined the electric potential to be 0. And then we have some source of electric potential, a battery, a power outlet, I don't know what it is. It doesn't matter. The point is we can make a wire be at electric potential Vn. And usually we do that by, think of it as a pump that pushes the charge up to a higher electric potential from 0 volts up. So that's basically what a battery is a charge pump. You can think of it that way at least. And then that charge at Vn can flow down through R1. Well, when it flows through R1, what is it doing? It's dropping electric potential. It is losing energy. That's the reason that resistor R1 gives off heat, right? Because energy has been lost from the charges as they fall to a lower voltage or to a lower electric potential at V out. And then that's not as far as they can fall. That's like halfway down the staircase, right? If both resistors are equal to each other, they can fall all the way down to ground potential. So hopefully that helps you understand a little bit more about things that you've probably studied in the past. So we're going to define ground as our 0 volts. Okay. Now let's take a multimeter and let's start measuring a few things. We'll put the black lead on ground. Okay, that is our 0 volt reference. So we'll put it there. And what if we put the red lead on ground? What reading would we get? We get 0. We're measuring a height from reference to reference. I mean, how high is the ground off of itself? 0 feet, right? You don't need a measuring tape to figure that out. But if you grabbed a measuring tape and you tried to measure it, your reference would be at the same height as what you're trying to measure. That's a 0 height, right? That's exactly what the multimeter is doing here. What if we take the multimeter lead and we put it on the big side? You ever notice there's a big side and a small side? It seems like you never get the plug the right way the first time if it doesn't have a ground on it. Why do they do that? I mean, there are plenty of devices where people have shaved down that thick side and plugged it in backwards and the thing works just fine. Why do they do this? Well, there is actually a reason. It turns out that outlet is not hot. If you stick the meter lead into the big outlet and the house is wired properly, or the outlet's wired properly, what you'll find is that there's no electric potential difference. The reason for that is because the ground side and that larger blade side are actually connected to each other back at the breaker box. Okay, they are literally connected together back there. Now, okay, if you really do this, you might get a couple volts difference, but the reason for that is because of induced current in the line as it goes along. That is reality. But theoretically it's 0 because, as I said, they are literally connected back at the box. Well, what if, so that's just illustrating those two are connected. What if we put the lead in finally the other one? Well, that one's called the hot leg. In that case, you'd get the 120, 115 volts AC, whatever it happens to be. It does vary a little bit. But you'd get high voltage. This is the one that can shock you. Okay, this is the one you don't want to touch. And don't touch any of them because it could be wired wrong. But this is the one that would certainly tend to shock you. It is the smaller blade side. Again, assuming that the house is wired properly. Well, what does that mean, 120 volts? Does that mean that it's an electric potential of 120 volts just above ground? Actually, it doesn't. Actually, what that means, your meter would have to be set to measure AC. And what it would do is it would actually rectify the current to measure it. All that aside, what this really means is that ground is here. The hot blade is going up above ground and then down below ground. So think of it this way. You've probably played video games, okay, and so maybe a side-scrolling video game where the character is running along on horizontal ground. They have to jump onto a platform that's moving up and down. Well, that platform sometimes is above, right, so you got to jump up, and sometimes it's below, so you have to jump down. And it continually oscillates above and below ground level. You see, that's all that's happening here, is electrically the smaller blade has an electric potential that goes above ground and then goes below ground. And so all that really means is current would flow from the hot blade down to ground when it's above, and when the hot blade goes below, then current would flow to ground down to in the other way. So this is just AC power. That's what it means. Now there's several different types of designs that are used for single phase power, which is what we've discussed so far. You might recognize some of these from your home. What you notice in the 120 volt AC is there are always a black, a white, and a ground plug, ignoring the pink shaded area right now. The green is ground, the white is called neutral, that's that bigger plug that I mentioned a minute ago, and then the hot leg, or the line, is the black, that's the one that will shock you. Okay, so you're probably used to seeing NEMA 5-15, that's your common household outlet. If you want a 20 amp circuit, then you need to get a NEMA 5-20, okay, to make the connections. And there's several here. Clothes dryers often use a 240 volt AC plug. You can see it there in the pink shaded area. And you might notice that in the pink shaded area there's either one green, one white, but always two blacks, right? There's always two black lines. What does that mean? Well, it turns out that in your home there are actually two hot legs that come into your house, but they're opposite phase from one another. So how does that look? Well, if you consider ground, the common or 0 volt reference as the green line here, one phase is going up above in electric potential while the other phase is going down. They're separating from each other like that, see? And then they cross and continue phasing this way. So this is 120 volt AC. Okay, that's each leg is 120 volt AC. But if you measure the difference between those two hot legs, then that's where 240 volt AC comes from. So you may or may not realize that there are two out of phase hot legs coming into your home from the transformer. And a lot of times when the power goes out, everything's just out, right? I mean, you turn on any light switch, nothing works. But sometimes something kind of interesting happens, and it seems a little more, I guess, paranormal or confusing. At least it was to me. It happened a couple of times when I was asleep, and I got up and I would work, I'd turn on one light switch and it wouldn't do anything, and I'd go into another room, turn that light switch on, and it worked fine. And I was like, what on earth is going on here? This is very strange. Well, what had happened was one phase leg was out, and so things that required two phases, for example, my air conditioner, it didn't work right. The fan requires 220, and when it only has one leg, sometimes it doesn't turn at all, the fan doesn't turn at all, sometimes the compressor won't work at all. In fact, I think usually the compressor doesn't work. But it's really surreal because it's like some things work, some things don't, and some things are just making strange noises like they're possessed or something, So it's a strange thing, but all that's really happened is a single phase has gone out. That's it. It's just not providing power. And so things that require 240 volt AC just simply don't operate properly. There's a link there. If you download the slides, you can follow. It's pretty good talking about electricity. I thought you might enjoy that. In industry, three-phase current is used instead. So there are three phases, and instead of simply being 180 degrees out of phase or polar opposites to one another, here the three phases are 120 degrees out of phase. And so if one phase is 1/60th of a second, then each phase begins 1/180th of a second after one another. Now that's 60 hertz current in our country, and across the pond they use 50 hertz current. Fewer cycles per second. It doesn't really matter, okay, at least for what we're talking about. It's similar ideas. So three-phase power is a very normal thing in industrial situations. And I've got a link here for you to see a little bit more about three-phase power if you want to dig into it. So now you can kind of recognize some of the wires that are on the telephone pole, right, or the electric pole. There are always three lines at least, and usually they're up high on the top, and those are literally three hot phases. That's how electricity is distributed, is by three phases. And that's why industry uses it so often, because you can you're basically closer to the source. You've got, well, there's another reason. It's because of the way that motors work, which is why we're talking about this in the first place. But anyway, so three hot legs then are sent into the factory. Now those hot legs are at high voltage. There's a couple different voltages, several different voltages in fact, that power is distributed around the country in, but they have to be stepped down. Nobody that I know of uses the high voltage lines as they are. So you always see transformers on the pole, and so you can see there transformer 1, 2, and 3 that step down the hot legs so that you have lower voltage going on to the building. So you see the insulators there, and the neutral line and three hot drop wires coming from the three-phase power. Now, if you want something that's more like 240 volt, you can take the difference between two of the phases. It doesn't really matter which two. You will get about 208 volts AC rather than 240 volts AC. In fact, a lot of equipment that's made to operate on essentially not really high voltage, but over 200 volt, less than 400, will operate on 208 or 240, either one. And that's because when you take two sine waves, even when they're out of phase with each other, if you take the difference, you still get a sine wave. And it's still about the same voltage as 240. So that's fairly common as well, is to use basically take two phases to make single phase relatively high voltage power versus 120 volt.